Today I really want to take the opportunity to cut through some of the buzzwords and try to land the concept of cloud in more concrete items. And specifically, how has Windows Azure as a product implemented some of those cloud concepts and made it easy for developers to go ahead and take advantage of. So let's start with a simple question. What is cloud? I've found doing this job for a while that if I ask this question to 100 people, I'm going to get pretty darn close to 100 different answers. And that's because there's just a lot of misinformation out there and a lot of just different opinions about what cloud means to each individual person. If you believe the hype, it's something like this, right? Which I think everyone in this room knows is not quite true, but I think we're going to get there someday. So let's get a little more concrete for a minute in the core concepts of cloud. When we talk about cloud, when folks talk about cloud, there's typically three sort of buckets that everything falls into. The first bucket is what we call IaaS, or Infrastructure as a Service. This is where you effectively lease virtual machines from a third party that are configured with an operating system. And you use those things however you want. You install your software on them, you configure them the way you want them, and you use them just like you use any other virtual server in your environment today, or physical server for that matter. The hardware provider is responsible for everything from the OS on down. If anything fails, the hard drive goes out, they're responsible for that. You're, on the other hand, responsible for that operating system level, keeping that thing secure and up to date, and all of your application stack. You have to install and configure and manage that. If something goes wrong, you have to go and fix it. You own the machine. You break it, you bought it. It's a great capability for a lot of existing applications that you want to maybe take from an on-premises virtualized infrastructure and take them into the cloud. This is an easy way to do that. So it gives you a lot of flexibility. Platform as a service, on the other hand, is one step up the stack. And for developers, this is really actually pretty interesting. What it means is that the cloud provider gives you not only the infrastructure as a service piece, but it also gives you the application runtime, all the way up through the OS to the application runtime. So as a software developer, all you need to think about and worry about is the code for your application. You have a defined set of APIs, a container that's going to run your application, and you don't ever need to think again about patching an operating system or doing security updates or managing configurations. All of that's handled for you by the cloud vendor. So you simply upload your application code, and off you go. And finally, software as a service, or SaaS. I think everyone's pretty familiar with this model. This is a third-party vendor delivering some kind of software to you, usually through a browser or device, and they manage everything. This is Gmail or Hotmail or Netflix. So it's almost not cloud. I think more and more people just think of it as an app. But in the background, that's being delivered as SaaS. So today we're going to focus on infrastructure as a service and platform as a service, because those are sort of the building blocks for you developers to put your expertise on top of in order to ultimately deliver SaaS-type applications. So let's drill in a little bit on that. So what does this really mean? We have these two terms, IaaS and PaaS, which frankly I personally don't like too much. So what does it mean to you? The first thing it gives you is agility. Okay? The notion that you have power and control as a developer over your infrastructure. I know many of you who are in large enterprise companies have a number of different hoops you need to jump through in order to get a simple server provisioned. Imagine being able to not only provision a server on demand, but being able to provision an entire environment with multiple servers for all the different tiers of your application on demand, on your schedule, to do your own testing and your development work without having to depend on IT department or others in your organization. It's a pretty powerful concept. Spinning things up, spinning them down, configuring them the way you want them, and doing it on your time. Agility. The next thing you get from cloud is this notion of application building blocks. And the concept here is that you don't have to reinvent the wheel. that's been done. All the heavy lifting in most of the types of applications that we build has been done already. You need to implement identity providers in your application. You may want to do, let's say, media streaming in your application. There's a lot of code that needs to be written to make that stuff work. And I assume most of you don't want to spend 80% of the time in your application writing code that somebody else has already written. So instead, let's just use an API. Cloud providers are building these sets of application building block services that you can hook into with simple APIs to add additional capability and functionality to your app with literally a few lines of code. Standing on the shoulders of giants who have been there before, who are going to actually maintain that service, by the way, in the future. I remember the early days of implementing like the Facebook and Twitter APIs for user authentication. I don't know if anyone in this room's done that. And having to go try to understand OAuth, token exchange protocols, and all of these things was a nightmare. Now, with something like Windows Azure Identity Services, a couple lines of code in my application, and Windows Azure takes care of that for me. All of that complexity goes away. That's the power of the building block services that you get from cloud. A core concept in cloud in general is paying only for what you use. So think about it this way. In the past, if you needed 1,000 servers to do a job that took an hour, your only option was to go buy 1,000 servers. And that would sit there idle for 23 out of 24 hours. And for the business leaders in the room, you know that's a pretty poor use of capital resources to go buy 1,000 servers that sit idle for 23 hours a day. And probably they're turned on the whole time too, because nobody wants to go in there and turn them on and off. So they're also burning, electricity and everything else. So we have a customer that's a financial services customer, and they need to crunch a bunch of data after hours. And so what they do is they wait until the markets close in New York. They spin up thousands of virtual machines, and they crunch all their data over the matter of a couple of hours. And then they spin those things back down. And it costs them all of a couple of dollars to do that. So you can think about the power of having that unlimited resource pool available to you at any time, being able to turn that on and turn it off. And basically, effectively, if the job is well written, it's a perfectly parallel program, you could effectively just decide how much time you want to spend solving that problem, and then just put on more machines to get to the time frame that you actually want. So it's a pretty interesting problem. And you're paying pennies for each one of those. So now let's talk about how Windows Azure has taken some of these things and kind of put it into the product and the platform that's available to you, and how you can actually take advantage of that. So first, let's look at the global physical infrastructure that is the underpinning for Windows Azure. We have a total of, today, 8 data centers around the world where Windows Azure customers can take advantage of all that infrastructure capability for running your applications. And you'll see here, the blue dots rather are roughly our data center locations, and the green dots are roughly our CDN nodes. So those are places you can edge cache content to give low latency experiences for users if you have them distributed around the world. And the interesting thing here is the Microsoft Windows Azure data centers are run by the same group, Microsoft Global Foundation Services, who's been building data centers and services to power Microsoft's offerings, 24/7 service offerings for more than a decade. So you think about things like MSN, Bing, Hotmail. The guys who had to build out all that infrastructure and figure out how to make it work are the ones who are helping our Windows Azure business by building all that infrastructure out. And so let's just take a quick look inside of one of these data centers to see what it looks like. Basically, they're the modular container units that have thousands of servers inside, and they're completely sealed. They're brought into the data center by these tiny but really strong men, slid into place. And once they get in place, they get hooked up to like 3 things: power, network, and water for cooling. And that's about it. They're sealed units. It's complete lights out operation. Nobody ever goes inside those containers once they're in place. If something happens inside, something fails, no problem. We just keep running that container until it's reached a certain level of degradation. and then we take it out and it gets refurbished and another one gets slapped in there. So you can see the type of efficiency that we're able to drive in this type of operation. And ultimately that means super, super efficient operation and low, low prices in terms of passing those resources on to you, the user. So let's talk about Microsoft's implementation of platform as a service. We call it cloud services. This is really the service that allows you to build infinitely scalable applications and systems that can have complicated architectures, multiple tiers, and deploy those things to the cloud as one unit. So you have an easy way to take those things, deploy them to the cloud, and manage and monitor them through the Windows Azure portal and service management APIs. You get automated application management and monitoring as part of this, and I'll show you how this works. So the unit of deployment in a cloud service package using Windows Azure Cloud Service is something called, the unit of deployment in cloud services is called a service package. The service package is effectively a glorified zip file. That's all it is. It has the code for your application inside, and it has some configuration data that tells Windows Azure how to run that code. If you want a .NET runtime, you don't have to do anything. If you want some other kind of runtime, you may put some configuration data in there to tell it what kind of runtime you want. But remember what I said, in Platform as a Service, all the runtime is configured for you. So you put that in once, you tell the system how to set up your runtime, and then all you have to worry about is that code. The other thing that's in that service package configuration data is how many instances of my app do I want. So in this case, let's pretend our service package contains a website. Just a simple website. So I have a bunch of HTML files in there and some images and whatnot. But I expect my website to be pretty popular out of the gate because I'm just that way. And so I need 4 instances of my site because I need to be able to handle the traffic that I expect. Okay? So I put the number 4 in my service configuration file to say I want 4 instances. So when Windows Azure gets this service package, it reads that metadata, and it says, OK, you need 4 instances of your app. I'm going to go provision you 4 VMs under the hood, get those things ready with the runtime components that you've specified, and then I'm going to take the code from your service package and image it onto each of those machines in a very consistent way. So now I have effectively 4 VMs with the runtime stack that I want and my code running on them. They're all exactly the same. The last thing Windows Azure does for me automatically sets up network load balancing across those instances. So any inbound request from any device from my website gets automatically load balanced across those 4 instances. Great. So let's say I misestimated the amount of traffic I was going to get. And in fact, I was maybe a little pessimistic on what I was going to get. And in fact, Oprah liked my website so much that she talked about it on Oprah's Favorite Things. Okay? Now I got a problem. I got to scale this thing up. Oh, oops, I jumped ahead. So before we scale, let's talk about what happens if something actually fails on this thing. Hard drives fail. It's probably happened to everyone in the room. Today, in the data center, on a production machine, when a hard drive fails, somebody gets a page and has to go deal with that thing. And there's a data copying and getting the thing rebuilt, and it's a major headache. Well, in cloud services, when a hard drive fails, Windows Azure recognizes that that hard drive failed, or something in that one instance, spins up a new one, re-images it with all the same stuff from before, takes the old one off the load balancer and puts the new one on. And you don't even know this happened. This all happens for you automatically. So having multiple instances running gives you a great availability story. OK, back to the scalability problem. I need to scale. Let's say I need to go up to 6 instances of my app. I simply go into the Windows Azure portal, drag a slider bar up to 6, and click Save. And within seconds, I now have 6 instances of my application running, all load balanced. Now, of course, Oprah says she loves my website. 6 isn't going to cut it anymore. Let's say I need like 92 instances. I simply drag that slider bar up to 92, click Save, and within a matter of just a few minutes, I have 92 instances of my application running. It took me about 5 seconds to drag, click, boom, and there they are. And then Oprah and all her friends can now enjoy my website. Okay? once the fad has kind of died down, I don't want to pay for 92 instances anymore, right? But I do have some new customers that sort of came out of that big wave, and I want to hold on to them. So I'm going to scale back down, but this time I'm going to scale back down to 10 instances. And again, all the while only paying for what I use. So effectively allows you to match your demand curve almost perfectly. You don't overbuy hardware, so you don't have stuff sitting around, and you don't miss those opportunities because you don't have enough capability. You simply move that slider bar, match that demand curve perfectly. So platform as a service really is the ability to focus on the application, not the infrastructure. Developers really shouldn't care about the operating system, if you think about it. Why should you care as a developer about patching an operating system? Your job is to write code, build great apps. Let's focus there. By focusing there, what you're actually doing is focusing on the business of business and adding value to the business rather than spending time on administrative things. And that ultimately is the bottom line, right? If you can't spend your time delivering value for the business, you're going to see a lot fewer of those. So it's all about optimizing your skills and the resources you have available to you. Okay, now let's talk a little bit about virtual machines, also known as infrastructure as a service. So Windows Azure supports virtual machines of either Linux or Windows. You have your choice. I know many of you probably have both running in your data center. We also have virtual private networking capability now, which allows you to actually connect virtual network in the cloud back to your on-premises infrastructure. So effectively, you can provision new VMs in the cloud, and they show up just like they're in your existing data center. So you can sort of have an infinitely expansive data center if you want to. And one of the great things about the way we've implemented virtual machines is that we're using the same hypervisor technology as we're using in Windows Server Hyper-V. So that gives you portability. If you're using Hyper-V today, you can take your VHD file, which is the disk instantiation of a virtual machine, take that thing, copy it up to the cloud, and rehydrate it up in the cloud. You can go create VMs in the cloud through the Windows Azure portal, configure them how you want them, and then pull them back down on premises. There's perfect symmetry and portability of virtual machines. So just show you what that looks like up and down. And then the other thing is, if you ever want to take a virtual machine and use it with a third-party cloud provider that supports that VHD format, you have the ability to do that as well. So there's no lock-in of any kind once you start using virtual machines in Windows Azure. You can bring them down, or you can share them with a third party. Well, my slide kind of went haywire there. Let's move ahead. So this is kind of the big overview slide of Windows Azure, and I'm not going to go through the whole thing because I want to get to a couple other things. But one thing to notice here is that we have the virtual machine offering we talked about. We have the cloud service offering that we talked about. There's also a third offering called Windows Azure Websites, which I'm going to show you, which you can think of platform as a service that's even more optimized for just websites. It makes doing web stuff even simpler. We have a whole bunch of storage options, and then in green are all these building block services that I talked about. Just simple APIs you can call to add great new capability to your applications. We have great SDKs for .NET and some other open source languages that make using all of these services very, very easy. So let's talk about building applications for the cloud. How do you build applications for the cloud? You all have a specific way that you build applications now. What changes? Well, within Windows Azure, the song remains the same. Okay? So let's take a look at what I mean by that. Let's look at a simple web application to start. So here I am in Visual Studio. I'm just going to create a quick ASP.NET MVC application. Let's call it VS Live Keynote. And I'll just take all the defaults here. All right, here's my simple ASP.NET MVC app. So let's change a little something here to make it make it ours. Okay, and then I'm just going to hit F5 and run this thing on my local machine, just make sure everything builds and works. And voila, hello VS Live. Simple ASP.NET MVC4 app. Okay, now I want to publish this thing to the cloud. So I'm going to show you the easiest way to do that. So here I am in Windows Azure. I've got my Windows Azure subscription. It's all set up. I want to go create a new website. And by creating a website here, basically I'm creating a container that's ready for my code. So I'm just going to go ahead and say create website. I'm just going to let it do its quick create. I'm going to just give it a name, VS Live Keynote 1, which has to be unique because of DNS. I'm going to deploy to North Central US because that's very close to here. And I'm going to go ahead and put it in this subscription. I have a couple subscriptions that I could put it in. So this just takes a few seconds to create. And once this is done, we can go deploy our code directly into this, this website. And I'll show you how easy that is. So this is done. So when I click on it, I get this little, this little bit of information about how to go actually deploy, where to get the tools, if I'm new, everything I need to know to get started with Windows Azure websites. But I already sort of know what I'm doing a little bit, so I'm going to download the publish profile. And I'm just going to save that published profile. It's going to go to my downloads. And now I go back into Visual Studio and I say, all right, I want to publish this thing. Yeah, I want to stop debugging. And I'm just going to import my published profile from downloads, which is where I just got it. Click OK, and click publish. And within just a few seconds, it's contacting my new Windows Azure website, deploying all that code to Windows Azure websites, and then it's going to fire up a browser of me now pointing at my new Windows Azure website. So note the URL here. This is live now in the cloud. So it's just that easy to deploy and publish a website to Windows Azure. So really nothing's changed. This is just an ASP.NET website. Yes, sir. Yes, so in general, if you're on pay-as-you-go pricing, everything starts as soon as you deploy something. Now, I'm actually on a free tier of this website. So with websites, you can deploy for free, and there's a way you can do it for free always. And there's some constraints with that. If you want to go scale to bigger instance types, then you need to pay. But I'm actually on a free. Everything I'm doing here is completely free. But now let's look at the scalability options. So my site's there. And now I want to go ahead and scale that thing. So I go back to my Windows Azure portal here for my website. And now I want to scale this thing. So I simply click the Scale tab. And you'll notice here I'm in free mode. If I want to go to a shared or reserved mode, which I'm not going to get too into the details right now, I can scale the instance. So I'm going to go to reserve mode. Reserve mode actually gives me my own virtual machine under the covers. So nobody else is using it. In free, you're in a multi-tenanted environment, sharing effectively the same hardware resources with other people's websites. But I don't want to deal with noisy neighbors, so I'm just going to go reserved. And I want a medium-sized VM with 2 cores and 3.5 gigs of memory, and I want 5 of them. So I just simply do that, click Save. You sure you want to do that? Yeah, I do. You can create up to 10 free sites. It's a shared multi-tenant environment. There's no... Correct. Correct. All right, that's it. Now I'm on 5 virtual machines. My website is automatically load balanced across 5 virtual machines within just about 30 seconds of tinkering and toiling. Okay, so yeah, it's easy. Do what you've always been doing. Just use Windows Azure to publish your site. That's easy, right? Well, it's not that simple. It's never that simple. There are a few things to keep in mind. So I want to walk through this. I'm not full screen here. Let me go full screen.
This isn't the same as deploying a web role, right?
This is not the same as deploying a web role. Websites is specifically for web applications, and it doesn't do worker role, it doesn't do things like that. But if you're just doing web, it's a lot easier to get started. The scale process is a little bit faster. You have multiple options for deployment protocols. You can use Git, you can use web deploy, you can use FTP. There's lots of different things you can do with websites that you can't do with web role. There's some things you can do with web role, obviously, that you can't do with websites. So there's some trade-offs there. It just depends on what type of application you're deploying. But if you're new to Windows Azure, you're doing a lot of web stuff, start with websites. Try it out. Understand if you're going to hit any of those boundaries, because you probably won't. And then if you do, then we have a conversation about going into a full cloud services web role thing, which is a little bit more complicated, but gives you a little bit more capability. So design for scale, this is the key element of cloud. Obviously that train was not designed for that. I don't think so anyway. There are handles all over it. But the point is you never know what's going to happen. You never know if you're going to be the next Instagram. You never know. You don't want to pay for being the next Instagram if you're not going to be the next Instagram. But you want to have that capability, so designing for scale. And what it means in the context of cloud, more specifically, is designing for horizontal scale. Anyone can design for vertical scale, right? Just go throw more hardware at the thing. Like, oops, I have a really poor memory management in my app. Just go double the RAM on that machine. Like, that's not designing for scale. Designing for scale in the context of cloud means being stateless in the way your application works. Don't store session state in memory on a machine. When your instances are being load balanced by that network load balancer, you have no guarantee of which one of those underlying VMs your user is actually going to hit. And in fact, if your user is talking to one of those VMs, and all of a sudden that VM has a hardware failure of some kind, which does happen, will happen, they're going to get load balanced to a different VM. All of a sudden their session state is gone if you're storing that session state in memory. So you need to think about how do you manage session state. Using distributed caching, using database, other options to do things like that to make sure that as users move between the various instances with the load balancer, that you're not going to run into any problems. So those are things to keep in mind. Let's see. The next one, we talk about scale, is designing for failure. So I don't know if you all remember, it was last Christmas Eve or 2 Christmas Eves ago. We were all sitting at home watching our favorite Christmas movie. This one's mine. And all of a sudden, that happened. Not exactly that, but something like that. And then that happened. I said, oh my God, this can't happen. Netflix can't go down. It's like, I thought that was impossible. I don't know what that's all about. And it made big news. It was all over the news. Netflix went down. Oh my God. Like Twitter goes down how many times a day? And like nobody cares. Just happy fail whale and everything's cool. But when Netflix goes down, people get pissed, right? So that was a big deal, right? Failure happens. Things break. One of the interesting pieces about the cloud model is we're using cheap commodity hardware to build all this infrastructure. It's actually designed to fail. Failure is built into the model. But you as application developers need to internalize that and understand it and build resiliency into your applications. That means putting data in more than one place. That means doing things like geo-replication. Never count on a single node or a single instance or a single anything, because ultimately that thing will fail. And we have lots of different patterns for helping you sort of get there. We have something called availability sets in Windows Azure. And availability sets gives you the ability to put resources that are working together. So if you have a database and you have a web server or other things, you put them in what's called an availability set. And what that means is that Windows Azure will make sure to distribute those things across fault domains so that they can't all fail at once. So like all your web servers, you'd put in an availability set to make sure that if they're not all in the same rack, for example, if the top of rack switch blows up, they don't all go down at once. It automatically distributes them for you. So if you're doing that in a traditional model, you got to sort of think, okay, I'm going to deploy one instance over there, I'm going to deploy one instance over there, one instance over there. By just putting them in something called an availability set, that's all handled for you. We already talked about geo-redundancy. When it comes to actually delivering a great service level for your customers, you obviously want to have the highest service level possible. And so by taking all these things into account, designing for failure, you can deliver better service levels. The interesting bit is, though, the further you get to the right, meaning the higher your SLA, the cost starts to explode. So you can have geo-redundant data being replicated to 27 data centers if you want to. You can have it go into Azure and go into other third-party places and have copies of your data laying everywhere, including on a hard drive under your mattress. But doing that is expensive, right? So you have to sort of think about, what is the real service level that my business needs for this application, and how can I get there in the cheapest possible way? Because 6 nines is very, very expensive, and also most of the time not really necessary. People say they want 5 nines or 6 nines or whatever. It's interesting to sort of double click on that and understand, what do they really want in terms of availability? What do they really need? What does the business need? And so one interesting way to think about this is to decompose by workload. And think about the components of your application and what their various service levels actually need to be when you're building them. So it's not only what you need to think about when you're building them, but also when you go to deploy them. What do you need to take into account? So one example here is, let's say you had a sports API that was servicing some large sports broadcaster or something like that. And they said to you, I need 4 nines uptime. Give me a 99.99 SLA on this app. You could say, okay, well, what does that actually mean? What it actually means is that you need something like 99% of the time the thing has to be up for team, player, stats, other information about the league and the games and whatever. That thing has to be working about 99% of the time. And during a game, boy, the live score stuff better be working. But when there's not a game going on, the live score stuff doesn't need to be working. So whatever you've built out for that, it really only needs to be working during games, which is far less amount of time than when games aren't going on. So try to think about how to decompose it into the various pieces and think about which pieces of the app really need that type of resiliency. Because if you're going to spend your money and your resources making something resilient, spend it where it actually has to be resilient. And then use sort of asynchronous background cheap storage to do everything else, because you don't really need it all the time. So design for interoperability. Think more like the web. Think more modular. How are these things going to plug into future things? Almost everyone I know who's building web applications today is taking advantage of the new like ASP.NET Web API stuff to expose APIs for everything as well, because they know their boss is going to come to them and say, hey, go and build a mobile front end for this thing. Go build an Android or an iOS client for this. All of that data that you're exposing through your website, might as well build APIs on there because you're going to need them. So think about interoperability and modularity. It's going to save you a time in the future. And last but not least, design for operations. Build measurable things into your application. Instrument that thing such that You can isolate, detect issues, roll back when you need to, and iterate. The great thing about cloud is I can deploy without a whole bunch of hoops. And so when issues come up, you're looking at the data, you know there's a problem, you need to fix it, go fix it and update. That's the great thing about it. The waterfall model is dying a slow death, and we're going to be able to be much more agile in this new world. But you have to have the data. Your app has to be reporting about its health, and so that somebody can do something with that information. One great example of this is, there's other things you can do in operations too. I always think about Netflix, their Chaos Monkey application. So for those of you who don't know, Netflix, even though their thing has gone down a couple times, it's one of the highest uptime services, particularly at the scale they're at, of any other service on the web. That's why everybody thought it could never go down, right? It's an unsinkable ship like the Titanic. So what they did is they actually built something called Chaos Monkey, and Chaos Monkey goes around and it arbitrarily breaks pieces of their application intentionally in production, so that they can be sure that they have the right resiliency mechanisms in place, that if something really does happen, not caused by Chaos Monkey, they're ready for it. And I can imagine how many issues Chaos Monkey has actually uncovered that they had no idea were there until they ran it. So you have to beat on yourself and beat on your app and try to test every possible permutation, because sooner or later, one random thing will fail, one random edge case will happen, and knowing those things ahead of time is going to save you a lot. Okay, so I know what many of you are thinking. This all sounds kind of neat, but I'm doing client-server dev in my data center. My boss or my organization is never going to go to the cloud because of X, Y, or Z. I hear you. I understand that this is a long evolutionary process. So I encourage you to think about new projects that are greenfield projects. And when those come up, take advantage of the cloud and look at the opportunities to use something like Platform as a Service to accelerate your development and design of your new project. Because I guarantee you, you'll be surprised at the amount of time savings and efficiency you're going to get from something like that. But I understand today you don't have maybe that capability. So I want to share with you a couple of things. One, you can take existing applications that are running today in virtual machines, and you have the opportunity to move those to the cloud intact. If you're having data center capacity issues, you need to be able to deliver capability to customers or partners in a more efficient way. You need to scale globally outside of your data center to reach customers in different parts of the world. Think about scenarios where you can actually take those VMs and put them in the cloud and take advantage of some of that global scale that you can't get today with your existing infrastructure. It's all there for you. With the virtual networking capability, you can actually connect your cloud resources back to your existing data center and do a lot of interesting things. Everything you deploy to the cloud can still authenticate to your existing Active Directory. You can still access all of the databases that are back in there. Be it there may be some latency in that scenario, but you have a lot of flexibility with that virtual networking capability. So that's one place to start. For developers, though, one place I really, really want to build a lot of awareness and thinking around this year is development and tests in the cloud. Actually, can I see a show of hands? How many of you in the room have an Msdn subscription? Okay, the vast, vast majority of you. How many of you knew that as part of your Msdn subscription, you have free Windows Azure? Okay, maybe 25, 30% of those who raised their hand before. The problem is the credit card? Okay, I'll talk about that. So let's first just take a look at what we can do in Windows Azure from a dev test point of view, just to sort of make it real. So I have here a Windows Azure subscription. Has one virtual machine running in it, which we'll get to in a moment. And let's say for a moment I have a application that runs across 6 VMs. It's got an Active Directory domain controller, it's got a database VM, a couple of web heads, and maybe another middle tier box that does something interesting. And I want to be able to test my code on all of those servers in the exact same way they work in production. So I want to take a mirror of production, spin it up myself on demand in my own sandbox with nobody bothering me, and deploy my code there and test it and see what happens. And maybe even apply some load tests to that and see from a performance and scalability point of view, what do I need to do? I can actually apply that load, see what happens, scale it out, and see, okay, how many instances are we actually going to need with this expected load? I can do all that myself as a developer without talking to anyone in IT. It's very easy. So what I've got here is a set of 6 virtual machines. And I've got a PowerShell script here. So everything you can do through the Windows Azure portal, you can also automate using either an API, we have RESTful APIs for all this stuff, or through PowerShell. And so what we've done is just created a simple PowerShell script for me that has my dev environment variables in there, and it's going to go spin up my 6-server development environment for me in my subscription. So I'm not going to go all the way through the PowerShell script, but you can see here I just set up some basic variables here about the storage account name that I'm going to use, the subscription ID for my subscription, because I have several that I want this to use. And basically, it's going to go through and set up each of those virtual machines for me. So I'm just going to go ahead and click Run. And this thing will start running down here. And it takes a second to authenticate against Azure and get going. And while that's happening, I'm going to show you something else. I've got another virtual machine up here called Craig's DevBox. And what is it? It's pretty self-explanatory. It's my DevBox. So I want to go write some code. I can just click on this thing and say connect. And what I get downloaded to my machine is a .rdp file, which will tell remote desktop all the information it needs to connect to the machine. Oops. For some reason, typing passwords on stage is 100 times harder than typing them at your desk. So I connect into Craig's DevBox, and voila, I have a workstation here where I can go fire up Visual Studio and start hammering on code. And at a certain point, I decide, hey, I want to write an app that uses a lot of memory. And boy, I don't really want to go to my boss and beg him for another dev workstation, because that's a fruitless exercise. And probably, even if he does say yes, it's going to take me a couple of weeks to get a new machine with more RAM and all these other things. So I have another choice, which is I go in here, and I say, OK, I want a dev box with 56 gigs of memory and 8 cores. Done. Now I can build that high memory-intensive application on my little Craig dev box, and nobody is the wiser, and nobody's spending money, and I'm not waiting for servers to arrive. It's just that easy. So now let's take a look at our dev environment script that's running. And it looks like it's succeeding here, so we should start seeing things popping up in the portal here momentarily. So right now, the Msdn offer as it exists today, wink, wink, is 750 hours of continuous use, which is basically one small-size VM continuously running. So you can think about that a few different ways. You want to go run a website nonstop, one machine, you can do that. If you want to spin up a bunch of machines to do some testing for a couple hours and spin them back down, you can do that. So it doesn't matter how many machines you use, you just got to sort of take into account the time aspect there. We are looking at potentially changing that offer in the future to make it even better for these types of scenarios. And I can't announce anything today, but we are working hard to make it even better. But with 750 hours, you can still get quite a lot done, particularly in a scenario where you're going to spin it up, run some tests, and spin it back down. All right, let me make sure I have both subscriptions here. So these things should start showing up. Okay, there's my first one. So my Active Directory domain controller is booting up now. You can see that just popped in there. And it'll probably take a few more minutes to get everything loaded up. So let's just move on. But before we leave, I want to just show you how easy it is to actually just start a virtual machine. So again, I'm in here in my portal. I'm on the Virtual Machines tab. If I want a new one, I simply click New. It assumes I want a virtual machine because I'm on the Virtual Machines tab. And I just say Quick Create, and I give it a name, VS Live Keynote. I can pick the operating system I want on that thing. And I have a lot of different options here. I have Server 2012, Server 2008. I can put SQL Server, a pre-configured SQL Server machine. I can put SharePoint, BizTalk even. I can even put Linux on it if I want to. All from this drop-down, I just pick which one I want. I give a administrative username here. Decide which data center I want that thing to be spun up in. I have a choice. And which subscription I want it spun up in. And I just click Create. Failed to configure my... Oh, I don't have access to that large size in this subscription, that extra 56 gig size, so I need to update my subscription. So that's all it is to start a new VM. And then within a few minutes, I can just RDP into that thing. I own it. I can configure it, install whatever I want there, and use it however I want. Shut it down when I'm not using it. And I don't get billed. So if it's running for 3 hours, I pay for 3 hours. That's it. All right. So where does that leave us? A couple things I want you to take away from today. One, most importantly, take advantage of that MSDN Windows Azure benefit. Go activate that thing today. It'd take you 2 minutes. Actually, I should have just done a demo on how to do that. But the URL here will take you right to the place you need to go to activate that benefit. And go spin up a VM and start playing around with it. Think about those types of scenarios where you're currently blocked by someone else in doing your development and testing. How can you use free virtual machines on demand to go do some of that work and get unblocked? At the same time, go play around with things like Windows Azure websites and think about how that's going to change the way you think about designing your next project. To be able to just easily deploy and update very, very fast, very, very quickly, and have the ability to scale on demand so you never run into capacity issues. Have fun, save time, tell your friends. Tell your friends means when you go back to work, go tell the people that you work with, hey, did you know you have free Windows Azure you can go play with? You need a VM to try something out or run something? It's already there. You probably didn't know that.